Again, 6A says right triangle trigonometry day 1. Today is going to be pretty basic, straightforward. Most of this stuff is just a little bit of review, just kind of reminding you about the other 3 functions. Tomorrow is definitely the more interesting of the 2 days, where we're going to look at identities of functions and try and work with some identities. So we have a right triangle. There we go. And in this right triangle, it says theta is an acute angle between 0 and 90 degrees. So we'll just put it in the bottom right corner. Is it writing on my? There it goes. So then any triangle, if we're just labeling it as the size of a triangle, if this is my angle, it always has a side opposite the angle, a side adjacent to the angle, and the hypotenuse. I'm not even going to put numbers here because this can just apply to any angle. So any angle always has an opposite side, an adjacent side, and a hypotenuse side. And that's pretty much what we talked about with the pre-trig worksheet. So when we did the pre-trig worksheet, we were able to define using SOHCAHTOA, sine, cosine, and tangent. But now we know the 3 reciprocals of sine, cosine, and tangent. So using SOHCAHTOA, Katie, the sine would be equal to what 2 sides of a triangle?
Opposite of that.
Right, opposite over hypotenuse. With the unit circle, we said the sine was y over r. So the y value over the radius. It's exactly the same thing as saying the opposite over the hypotenuse. But the unit circle deals with an ordered pair. A triangle deals with the 3 sides, the adjacent, the opposite hypotenuse. So right across from it, the cosecant, Katie, would be what? So we know the sine is opposite over hypotenuse. The cosecant could be,
Hypotenuse over
right, the hypotenuse over the opposite. Because they're reciprocal functions. A reciprocal function means take what you have and flip it over. So if the sine is opposite over hypotenuse, the cosecant is the hypotenuse over the opposite. Or with the unit circle, we said it was r over y. So same thing, we're just now thinking of it as a triangle and not a point on the unit circle. So Marie, the cosine is adjacent over hypotenuse. So the secant would be? Right. And then Paige, the tangent is?
Opposite over adjacent.
And the cotangent would be then?
Adjacent over opposite.
Right. We said before the tangent was y over x, cotangent was x over y. This means the exact same thing. We're just now thinking of it strictly as a triangle instead of finding a point on the unit circle. But really, the 3 triangles, actually 2 triangles that we've talked about, create the unit circle. So it just kind of depends on which perspective you want to use. You could always just draw a triangle. You don't have to think of it as being a point on the unit circle. So if you look at the problem underneath, this actually wants us to find the 6 trig functions. You have a triangle drawn. We'll put the angle down here at the bottom. And I believe you have a side of 5 and the bottom one labeled as 3. So this would not be on the unit circle because the unit circle has a hypotenuse of 1. So this is just a right triangle. And we want to see if we can find the 6 trig functions. How would you find the opposite side of the triangle? If you know 2 sides. David?
A squared plus b squared equals c squared.
Yeah, so a squared b squared equals c squared. That good old Pythagorean theorem that you learned, I don't know, probably sometime in middle school. So if you know 2 sides, you can always find the third by using the Pythagorean theorem. We'll say b squared is 3 squared, c squared is 5 squared. So we would have 25 minus 9. So David, your vertical side is 4. The other way that you could have thought about this, if you have the numbers 3 and 5, 4 is always another side. It's called the golden ratio of a triangle. A 3, 4, 5 triangle, those numbers always go together. So 3, 4, 5, if you have 4 and 5, the other side is a 3. Does anybody know another just like set of triple? 30, 60, 90 would be the angles, but the sides. So the sides of here, the lengths of the sides is a 3, 4, 5 triangle. There's one that's also 5, 12, and 13. So if you have those three numbers, or two of those three numbers, they always go together. So it's a special triangle ratio. 3, 4, 5, 5, 12, 13. I think there's a 5, 25, 24, 25. There's a couple of different values that are always work for a triangle. Pythagorean theorem always works as well. So this wants us to find the sine, cosine, tangent, cosecant, secant, cotangent using the 6 definitions that we have above. So not on the unit circle, just on a little triangle that we have pictured here. So Nina, if the sine is the opposite over the hypotenuse, those numbers would be 4/5, and then the cosecant would be?
3/5. Oh,
No,
sorry.
you gave me the cosine, 3/5. Just go down. The tangent is
4/3.
4/3, yeah. And then Nina, to find the other 3, what would you do?
You just flip this.
Yeah, you just flip the 3 that you already have. So right across from it is its reciprocal function. So that means the cosecant is 1 over the sine, or take the sine value and flip it. So once you have the 3, the other 3 are found just by flipping. So reciprocal functions, buddy functions. Questions? So we pretty much already talked about those, except we talked about them as an angle in the unit circle. The angle being like pi over 6, 4 pi over 3. We found the ordered pair x, y that went with it, and then using that ordered pair, we were able to find all 6 functions as well. Just depends on like what you're thinking about when you see a specific type of problem. This wouldn't relate to the unit circle because the sides aren't the same. It has to have a side of hypotenuse of 1 for it to be directly related to the unit circle. So underneath, this one does give us the 45, 45, 90. So we want to find the sine, cosine, and tangent of a 45-degree angle. If the angle, one angle is 45 degrees, the other one has to be 45 degrees as well. They have to add to be 180 inside. We know nothing about the lengths of the sides. So you just have a triangle drawn. There aren't any numbers listed on the side. If you have a 45, 45, 90 triangle, what do you know about the sides? David?
Is that like square root of 2?
Yeah, well, not even that, but like how would you find it?
Square, it's like a square root of 2.
Yeah.
And
So-
then 2a.
These guys are just A. You're giving me the other one then too. I think you're mixing the two together. So if you have a 45, 45, 90 triangle, 2 of your sides are the same, so that's just A, or you could use B, or you could use X, it doesn't matter. And the hypotenuse is A times the square root of 2. You don't need to know the length of the side to find the sine of a 45-degree angle. Because if I know the pattern, any side of a 45-degree angle, these 2 sides have to be the same length. It doesn't matter what their length is. If we want to find the sine of a 45-degree angle, let's just say I use this one here. It doesn't really matter. Opposite is A, whatever A happens to be. The length was arbitrary. Hypotenuse is A over the square root of 2. Jared, what happens with the A's? They cancel. So the length of the side actually doesn't matter because you're taking that side length and dividing it by that side length. So really what we have is 1 over the square root of 2. And Jared, 1 over the square root of 2 is? Square root of 2 over 2. Now maybe you already have that memorized because you have the first quadrant of the unit circle memorized, which is awesome. But this is another quick way that you can find that value. You can draw yourself a little triangle. The sides are the same. They could be any length. That's why I just have them as a variable. And the hypotenuse is the A square roots of 2. So that length of the side is really canceling, and we're just left with 1 over the square root of 2, or the square root of 2 over 2. So the cosine of 45 degrees is the adjacent, which is still side A, length A, over the hypotenuse, which length is A over the square root of 2. And again, that's the square root of 2 over 2. Because the hypotenuse and the adjacent sides are, the opposite and the adjacent sides are the same. And the tangent of 45 degrees is equal to 1. Yeah, because it's A over A. The opposite side is A. The adjacent side is length A. Well, if the lengths are the same, then the tangent of 45 degrees is just equal to 1. So instead of using the unit circle, you could sketch yourself a 45, 45, 90 triangle. It doesn't matter what the side is, the length of it, as long as you remember the pattern of those sides. So the two sides are A, the hypotenuse is A times the square root of 2. Doing the same thing for example 3. Find the values of the cosine of 60, the sine of 30, the cosine of 30, a little degree symbol disappeared, and the sine of 60 degrees. So, I don't know, maybe this side is a little shorter. Based off the angles they're giving us, it's a 30, 60, 90 triangle. Paige, do you remember the values that go around the 30, 60, 90 triangle?
Yeah, the hypotenuse is 2a, and then across from the 30-degree angle is just a, and then the leftover side is a square root of 3.
Now you have your triangle drawn. Knowing what you know about SOHCAHTOA, find the cosine of 60, sine of 30, cosine of 30, sine of 60. So sometimes drawing yourself a little picture, a little diagram, either a triangle or like the first quadrant of the unit circle. If you have those little pictures drawn, a lot of problems we can kind of find solutions for based off of two triangles or that first quadrant and the 5 ordered pairs of the unit circle. So Aaron, the cosine of 60 degrees is
A squared is 3 over 2a
which simplifies to just be.
squared 3 over 2.
So that's looking at the bottom right corner. So Aaron, then it switches to the top 30 degrees. The sine of 30 degrees is
A squared is 3 over a, or just the square root of 3. A over a squared is
wait. I think you gave me sine up here.
3.
I think you did. Alright, so let's start over, Aaron. So here's 60 degrees. The cosine is the adjacent over hypotenuse. So the adjacent is, there you go, a over 2a. So that's just a half. The sine of 30 degrees is also a over 2a, which is a half. And then going down below, pile the cosine of 30 degrees is,
Square root of 3 over 2.
right, because we have a square root of 3 over 2a, which is the square root of 3 over 2. So now we're looking at the adjacent, and the sine of 60 degrees is
Square root of 3 over 2.
square root of 3 over 2. It's exactly the same. Questions? So you don't need to know the side, the actual length of any side of a triangle. The sine and cosine values would be exactly the same no matter what the length is. So if you flip the page, so it says because the angles 30, 45, and 60, which are really pi over 6, pi over 4, pi over 3, occur so frequently, one of the ways that you can find the values is to just construct a triangle. The other way to find the values would be to do that first quadrant of the unit circle and then just list those ordered pairs. Either way, you've got to remember something. So either you have to remember the pattern to the two triangles, or you're going to have to remember the 5 ordered pairs that correspond to the unit circle. Some of you might already have these memorized, especially probably the sine and cosine values. But the sine of a 30-degree angle is your y value of the unit circle. Anybody know what the sine of 30 degrees is? David? 1/2. So David, the cosine of 30 degrees would be square root of 3 over 2. So on the unit circle, here's my x, sine is y. That creates our ordered pair that goes along with pi over 6 on the unit circle. Or you could make a triangle and use the 30-degree angle of a triangle. The next one, we have 45 degrees. So Anna, do you know what the sine of 45 degrees is?
The square root of 2 over 2.
And the cosine is also?
The same thing. Square root of 2 over 2.
Yeah, square root of 2 over 2. And again, you have your x value and your y value. That would be pi over 4. And then the last two pairs here, we have the sine of 60 and the cosine of 60. So Marie, the sine of a 60-degree angle is?
That would be
Yep, square root of 3 over 2. It's supposed to be a 3. And then the cosine is 1/2. So how can you find tangent of 30, 45, and 60? David?
Put the sine over the cosine.
Yeah, so tangent is sine over cosine, y over x, opposite over adjacent, however you want to think about it. You've got 3 different ways to think about finding the tangent. So tangent of 30 degrees is the sine value divided by the cosine value. And when you divide, you're really multiplying by the reciprocal. So 1/2 divided by the square root of 3 over 2 is really 1/2 times 2 over the square root of 3. And David, that becomes square root of 3 over 3. So the tangent of 45 degrees would be our sine divided by cosine, and that's just 1. And then David, the tangent of 60 degrees is just the square root of 3. So I know you have something down here because I have 4 little circles, and I think it says, what do you notice about the sine of 30 and the cosine of 60? The sine of 60 and the cosine of 30. Mine disappeared. What do you notice about the sine of 60 and the cosine of 30? And the sine of 60 and the cosine of 30. Those guys are the same. Why do you think they're the same? What's special about their angles, David?
They are complementary.
They are complementary. So they are the same. And we'll say they're the same value, the angles are complementary. So if you have the sine and cosine of complementary angles, then the sine and cosine of those complementary angles will be the same. And that is the little property underneath. It says cofunctions of complementary angles. That means it's either 90 degrees or it could be pi over 2. So cofunctions are just two functions that are equivalent values if their angles are complementary. So the sine of 90 degrees minus an angle is equal to the cosine of that same angle. So the sine of 40 degrees is equal to the cosine of 50 degrees. The cosine of 40 degrees is equal to the sine of 50 degrees. That's all that's saying. The next pair would be tangent and cotangent. So tangent and cotangent are cofunctions. So now we have this reciprocal function, but we're talking also about cofunctions. So angles must be complementary for cofunctions to exist. And then the secant and the cosecant are cofunctions if their angles are complementary. So at the bottom here it says find using cofunctions of complementary angles. We're not putting this in the calculator. We're just going to show like which two functions would be equivalent to each other. So if you have the sine of 62 degrees, that's going to be the same as the cosine of what angle? So if they're complementary angles, and I have the sine of 62 degrees, what function would that be the same as, David?
28.
Yeah, the cosine of 28 degrees. Because 62 and 28 make 90 degrees. So if the angles are complementary, then the cofunctions are equivalent. The next one's a little trickier because we have the tangent of pi over 12. So tangent and cotangent are complementary, but we need to figure out what the complementary angle is. How would you figure that out, right?
Well, since you could figure out, okay, what do you need to make it pi over 2, which would be 6 pi over
Good.
12, and you subtract that to get
Nice. So she said, what do you need to make it pi over 2? So what number plus pi over 12 will give us pi over 2? And this is really 6 pi over 12. So 5 pi over 12 plus another pi over 12 gives us 6 pi over 12. So those again are co-functions. So co-functions are equal when you have complementary angles. So they add to be 90, they add to be 5 pi over 12. Or I'm sorry, pi over 12. 6. 2. Questions? So I'd like you to flip 2 pages. And it should say page 7. There's 3 word problems on page 7. This is part of your homework. I just wanted to kind of start you off with it. And I thought we'd look at example 3. Example 3 is a flagpole problem. So we can use right triangles to create a lot of different things in nature. We can figure out the height of a tree branch. We can figure out the height of a flagpole. We can figure out angles that correlate with those. So this one here, we have a 40-foot flagpole, and it's casting a 30-foot shadow. So draw yourself. If you really want to draw a flag, you can. My example of a flag. So here's our flag blowing in the wind outside. Yesterday there was a really strong breeze all day. And that flagpole is 40 feet. And then it casts a shadow, which means that we have to have a sun somewhere. So up here is our sun, casting a shadow on the ground, and that shadow is 30 feet. It wants us to find the angle, which we're saying is the angle of elevation of the sun. So if we make ourselves a triangle from the tippy top of the flagpole, meeting with the bottom of our shadow, the tip of the shadow. We want to know what the angle of elevation of the sun is. So that means that we're looking at the angle that would be elevated to look up to the sun. Not the angle coming from the sun, but we are looking at the angle that if you were laying on the ground at the tip of the shadow, you would be elevating your head to look up to the top of the sun. So how do you approach a problem like this? This is like a word problem. We're trying to find the angle. David, what do you think?
So you're going to set up as tan theta equals 40 over 30.
Okay, so why did you say tangent?
Because you only have your opposite and adjacent sides.
Right.
You don't have hypotenuse.
And we actually don't need the hypotenuse, but you have, as he said, the opposite and the adjacent sides. When you have opposite and adjacent, that's the same thing as having the tangent. So in SOHCAHTOA, tangent is opposite over adjacent. He said that would be equal to 40 over 30 because the opposite side is 40, the adjacent side is 30, which really, if we reduce 40 over 30, that gives us 4/3. Okay, David, we need to find the angle. So how do you find an angle?
So you do the inverse tangent. So
You have
tan
physics, right?
Yeah.
Yeah.
Tan negative 1, 4 over 3.
Good. So to find the angle, it's kind of like solving for x, except you can't divide by tangent. So instead of dividing by tangent, to find the angle, we use what's called the inverse tangent. So to get rid of tangent, if I use the inverse tangent, then they cancel each other out. If you have x squared, you take the inverse of it, which is the square root of x, they cancel each other out. So these are inverse functions that cancel each other out. In your calculator, if you go to the mode button, which is at the top of your calculator, make sure your mode is in degree, because it makes sense to have an answer in degree form and not radian form when we're talking about word problems. So if you go to mode, the third one down, it should say radian versus degree. Just make sure degree is highlighted. There are times when we'll need to use the radian button. So you're using second tangent and then typing in 4/3. And Katie, you got an angle answer of 53.13 degrees. So if you were laying down or sitting at the tip of the shadow, you would be elevating your head 53.13 degrees to see the top of the flag. So the other two problems are not worksheet or homework. And then there's some book problems that are just dealing with right triangle trig. So you'll be labeling a triangle based off of the two sides they give you, finding the third side, and then getting the 6 trig functions. Questions?
You can use like the right triangle. Can we just use the unit circle for
You
everything?
can just use you can use whichever you want. So if you like using the unit circle, then you can use the unit circle. If you'd prefer to use the right triangles, you can use the right triangles.